Alright guys, so we are doing Precalculus and we are on verifying inverse functions. So here are, they will give you like tables, right? The tables, you see these two tables, and your job is to find the values of s of t of x. So for the composite functions, you're gonna go with the inside. You deal with the inside first and out, right? So you go over to your t of x, which is this table right here, and you find your 12. What does that correspond to? That's -1. Okay, so you're done with this, and you get your -1 as your x for s of x, right? So for your s. So for your s, you're gonna look at this table right here on the left, and you will find that -1 corresponds to 12. So you see here 12, -1, -1, 12. So okay, interesting. So let's try another one. So the question that is here presented here is, are functions s and t inverses? So s representing the s of x, t representing the t of x right here. So are these functions inverses? So we kind of get a clue here, -12, -1, -1, 12. But we're going to go on to 18, alright? So 18, that's the next plugins. So you find here 18 corresponds to 2, okay? You take your 2 over here, 2 corresponds to 18, so that'll be 18, right? So 61 corresponds to 61. Wait, 61 corresponds to 8, and 8 corresponds to 61 again. So you see, they are all the same, right? They're all the same. They gives you the answer that was originally presented here, right? So you will conclude that they are indeed inverses. Okay, and move on to the next more table examples.
We already know
but
that
this time is not tables anymore. It's like they give you two functions right here, right? You test out the values yourself. So you're gonna test out your values yourself. Then you start with 1 and you get 4, and you start with 2, you get 7, right? But when you get to negative numbers, does that give you the same value? If you plug in -2 over here, that gives you 4, and then plus 3 is 7. But if you, right, it's the operations of inverses it, then you get your 7 to the new function here, and 7 minus 4, 7 minus 3 is 2, right? So we will conclude that, okay, -2 gives me 7, but 7 gives me 2. So that's not -2. This is not -2, therefore I will not conclude this as inverses, because if only one point failed, then the entire thing is not inverses. Okay, so if you do this as well, if you plug in this entire g of x right here, and you plug it into this x right here, and you'll get x minus 3 square root and what? Squared, right? So that gets rid of the square root. So you're left with x minus 3, and plus 3, you get x. Okay, that works. But how about the other way around? X squared plus 3 minus 3, and then you got x squared and square root. So x squared square root, what is x squared square root of that? Does that gonna get us x again? Probably. Or or I can argue that it's gonna be negative, right? Negative, it can be a negative number, right? So that will be plus and minus. The answer will be plus and minus. Both will work because your square will get then whatever number you have there to become positive, and you take a square root of that is the positive number as well. So you can either have negative and positive number, so that doesn't work, right? So they are not inverses.
We know that these are
They are not inverses. Right? Okay. How about the next one? Right here.
your power is just going to be x plus 7.
Okay. So we have x plus 7. That's what we're trying to do, right? With the previous question. X plus 7 square, no, cube, right? Cube of that, and minus 1. And how about here? G of x equals to square cube root x plus 1 minus 7. Okay, so you again do this and that, right? This and that, and you try to find if that gives you the same term, the same expression at the end, right? And if in this case it's going to be x. And how about this line of calculation here? Supposedly this will give you x as well, right? Then we can conclude that they are both they are inverses indeed, right? Okay, so you then do your calculations. That is easy calculations. That gives you x, and the other way around, that gives you x as well. So you conclude that, hey, I plug in the x right here and then I get x, and then I plug in the x the other way around, then I get x as well. So input equals to output, and then I put the output as our new input. That gives us the new output, that is our old input. So, which is really interesting, and that is the essence of inverses. Okay, and then we try to go over here.
Let's say that
We have, and again with two functions, f of x and g of x, and then you do the same thing. That gives you x plus 3. And how about here? Does that give us x plus 3? No, it does not. It does not. So these are not inverses, right? Not inverses. Okay, you can see right here. Okay, so that's the trick. That's the easy. So you put the g of x inside of the f of x. Doesn't matter the g, f, doesn't matter the acronym. It's just that you put one into the other one, and then the other one put it into the original one. So this crossover, and then you'll find that if they are inverses or not. Okay, for this, we'll try this one, right? So you put the g of x inside of f of x. So 3x minus 1 will be going to your x, right? So for your numerator, you're left with 3x, because minus 1 plus 1, you get rid of that. And 3x divided by 3 is what? Is x. Okay, easy expression, then we remember that. And then the other way around, you put this entire thing, the fraction, right, into your g of x, the x of g of x, right? And you get rid of the 3, right? 3 in the denominator and the times 3, right? You cross that one out, and you left with x plus 1 and minus 1. So you say, okay, so that's x, and the other way around is x. So they are both x, so they are inverses, right? So you do that for every kind of examples right here, right? So wherever they gave you two functions and test you on whether you can verify they are inverses or not, then you do the same thing. So you put this right here, that will give you x. Okay, so that's x, and then the other way around, x, right? So yes, correct. Okay, let's move on. So that concludes everything. That's the thing. That's how you verify the inverses. Okay, so good luck on your test and thank you for watching.